guys, and welcome to another UPE Python tutorial. Today we're going to be going over lists, sets, and tuples. So I'll start by going over lists first. Alright, so a list is just a container of things. You can put anything you want in it. You can put strings, you can put integers. It's not defined or restricted in any way as to what you can put inside of it like other languages. So let me just show you how you define a list. So I'm going to call my list workers. And I'm going to put Michael, Jim, Pam, and Creed. You can see it's office themed, for all you office fans out there. And I can print workers. So right now, I got my workers list. It has these strings, these workers, and I can print it. So if I press run, all right, printed the list out. Just how I stated it here, basically. And we can print the length of the workers, the number of elements inside the workers list. All right, if I run that, we get 4 elements inside the workers list. 1, 2, 3, 4. Yep, perfect. We can also index and print certain elements in the list. So if I wanted to print Michael, pick out Michael in the list of workers, I would do workers 0. So this is list indexing. List indexing starts from 0 and then increments by 1 each time. So this is index 0, this is index 1, this is index 2, and this is index 3. So 0 is Michael, so it should spit out Michael. Yep, so it spits out Michael. So I chose Michael from my list of workers. All right, and you can also print the last worker if you want. So the last worker would be 0, 1, 2, 3. Change that to a 3. Run it again. Prints out Creed. All right. And we can also do some reverse indexing with lists. So if I did list -1, see what that prints out. That's going to print out Creed because it's indexing in reverse. So the first one in reverse would be Creed. And then if I did -2, it's going to be Pam. And then -3, -4. That's how reverse indexing works with lists. And I can also choose 2 workers if I want. So if I wanted to choose 2 workers, I would choose my starting point, which would be Michael. I'm going to start at Michael, and then I'm going to try and choose Jim. So I would actually put 2 and not 1. So let's see what happens when I do that. See right here, it picks Michael and Jim. So it does start at Michael, which is index 0, but it ends at Jim, which is index 1. So that's kind of counterintuitive, but that's just the way Python works, and there's good reasons for it. But just keep that in mind for now. When you're trying to index multiple elements, it will choose one less than the ending point that you put in there. So just keep that in mind. All right, so what else do we get? Oh yeah, and if I remove this 0, it'll just assume that we're starting at 0. So it'll spit out the same thing. So if you see that in code, just know that it's the same thing as putting 0 there. Okay. And likewise, I could do it the other way. Let's say I wanted to start at 2 and print out the rest of the list. Say I don't specify anything here. It's just going to go all the way to the end. See? So it starts at 2, 0, 1, 2, Pam right here, and then it goes all the way to the end, which is Creed right here. So So let's say I wanted to add more workers to the list. Let's say we hire another person. So what I can do is, let me just delete this. I can append another worker. So workers.append. So I don't know if people went over this in other videos, but this is a list method, basically, is what we call it. That anything with a dot something, it's a method. It just does something to that list, in short, in simple terms. So dot append, and then I want to add Kevin. Because that's my favorite character.
At least once a year, I like to bring in some of my Kevin's famous chili. The trick is to undercook the onions. Everybody is going to get to know each other in the pot. I'm serious about this stuff. I'm up the night before, pressing garlic and dicing whole tomatoes. I toast my own ancho chilies.
All right, so this is appending or adding Kevin to the end of this list. So I should, if I print out this workers after I appended Kevin, it should be Michael, Jim, Pam, Creed, and Kevin. That's what it should be. All right, let's print out workers. Okay. All right, yep, just exactly as how it happened. So Kevin's at the end of this list. I can also insert Kevin if I want to. Let's say I don't want to put him at the end of the list. I want to put him before Michael or something like that. I don't know if you want to do that. So you do workers dot insert. This is a new method. It's the insert method. It'll insert it in the index before that you specify it at, if I said that correctly. So say I specify index 0, it's going to put Kevin before Michael, because Michael's at index 0, so it's going to put Kevin right before index 0. All right. All right, and now if I print workers, see that Kevin's right before Michael, right before index 0, right there. All right. So now, let's say I make another list of workers. Just a separate list. We'll call it workers 2. And we'll have Angela. We'll have Oscar as my second workers list. So let's say I wanted to add that second list of workers into my main list of workers with Michael, Jim, Pam, and Creed, and just one nice big list of workers. I can do, like, the most intuitive thing would probably be like workers.insert or workers.append. Let's just try workers.insert, and we'll put them right before Michael at index 0. All right. So let's try that. See what happens. Okay, so we got them in there. But you see the problem here? So at index 0, it's the whole list workers too. It's not Angela then Oscar, like as two separate elements. It's the whole list, so that might create some problems later in code. So you can see here if I print workers at index 0, it'll show us that whole list workers too. Now there's a better way to do this. Let me just show you. It's just using a different method. So instead I could do workers dot extend instead. Put it at 0 and then workers underscore 2. And let's see what happens. Oh, you don't put a 0, you just put the list. It kind of works like append basically. So it just combines it to the end of the list. Let's see what happens here. All right, you see now we have this nice big workers list combined together with Angela and Oscar, and Angela and Oscar are each their own separate elements. So it's works out pretty nicely. All right. So let's say I wanted to take away a worker from this list. So let me get rid of this whole thing right here. Let's say we're going to fire Creed. All right. So I do workers dot remove Creed. All right. Let's see what happens. See? Creed's gone. He's fired. It's just Michael, Jim, and Pam after we remove Creed. So that's just another method. And we can also reverse this list of workers. So let's see how that works. This is the reverse method. So all I do is call workers.reverse. And it'll reverse them in alphabetical order, basically. So you'll see what happens here when I print it. So you see, we have Creed, Pam, Jim, Michael. All right. We can also sort our lists. So this, if I call dot sort on workers, it'll sort them in alphabetical order. But maybe it's more intuitive if you see it with a list of numbers. So I'll make a new list of numbers. Let me just kind of make them out of order. 5. All right. So I'll do workers.sort, and then I'll do num.sort. That's what I called it. All right. And then we could see what happens here. All right. So we have Creed, Jim, Michael, Pam, all in alphabetical order. And then we have 1, 2, 3, 4, 5 sorted at least. So now let's say you don't want to change your list. I guess you don't want to keep the original list sorted. You can actually, let me just get rid of some stuff here. Say I want to keep that numbers list unsorted. I want to keep the original state. So I can do this. Make a new list that's sorted. I'll call it numbers sorted. And you can use the sorted function. So now if I print num sorted and then I print num, you'll see that num isn't changed, but num sorted is changed because it's a sorted version of that num list. Because all these list methods that we use, all these num dot extend, num dot remove, they physically change the list. So sometimes you don't want to change the original list. So it's just something to keep in mind. All right, you can see the original list is the same, and the new list, this sorted num is sorted, but the original list is untouched. So it's just something to keep in mind. So I can actually do some other cool stuff with it. So let's say I wanted to get the max number in this nums list. Well, I would just use the max function. So it'd be print max num, and then let's say I wanted to get the minimum number in the list. Use the min function. So it should print out for the max 5, and then for the min 1. So let's see what happens. Yep, we got 5 and 1. So it's just like another function that you can use on these lists, and it'll help you out. So let's say I wanted to get the index of a string in a list. So let's say I wanted to know what Pam's index was for whatever reason. I can use the index method and it'll tell me her index. So she's at index 2, 0, 1, 2. So that's nice. And then you can actually test if Pam is in the workers list. So you could be like, Pam in workers. Let's see what it says. Returns true. Yeah, she's in the workers. And then likewise, if I put someone that wasn't in the workers and asked it if like Kevin's in workers, should say false. Yeah, says false. Awesome. So you can also lists are iterable, so you can iterate over lists. So let's say I wanted to iterate. So we'll say for worker in workers, I just want to print each worker's name. So you're saying for each worker in the whole list workers, I want to print worker. So it should print Michael, Jim, Pam, Creed, all on new lines. That's what it should do. Yep, perfect. Michael, Jim, Pam, Creed. Awesome. All right. So let's see. So that's pretty much the basics of lists. Let's just go over tuples for a little bit. So tuples are kind of like lists, but they're just immutable in a way. So let me just show you what that means. So I'm going to make a workers tuple, the same thing. So instead of being denoted by the brackets like lists, they're denoted by parentheses. Michael, Jim, Pam, and Creed. So we have our tuple, we have our workers, and let's see what happens if I try to index one of these workers. See what happens. So if I do workers top of 0, actually let me just print that out because just top of 0. It's not liking that. Oh, see, sometimes you make just these weird mistakes, but I just forgot to put a quote here, and it wasn't completed, I guess. So let me just do that again. All right, so it spits out Michael. So far, it's the same exact thing as a list. But let's say I want to change something inside that list, or inside that tuple, I guess. So let's say I want to set workers top of 1, Jim, and I want to set him, I want to replace him with Kevin. Let's see what happens. All right, so we get an error. So we did nothing wrong syntactically. This is good syntax, but we're using it for the wrong data structure. So tuples are immutable. So you can't really, once you declare things in tuples, you can't really change them. They're used for values that you know they just won't change. That's what they're good for. Very rarely will you actually use them. I mean, in your classes, but they do have their uses in the real world. So, but you just have to keep that in mind that you can't change them. That's the main caveat of tuples. All right, that's the main thing with tuples for the most part. Now we're going to go over sets. So sets, it's kind of like the same thing as in set theory. It's just an unordered list with no duplicates, and they're denoted like this. set. And instead of brackets or parentheses, they're denoted with these curly brackets, like that. That's how you denote a set. So let's say I wanted my workers set. So I got Michael. Well, let me put that quote there. Jim. Pam. And Creed. That's my workers set. So let's say I want to check if Jim is in my workers set. So sets are optimized for this, checking if something is in the set. Versus like lists, it might take a little bit longer. I mean, you won't notice it, but it's just that sets are optimized for this kind of checking. And it might make a difference in a big project that you're doing. You never know. But for our purposes, it really won't. So let's see what happens. Oh, and I misspelled this. See? You can catch these errors before you do them. Yep, true. All right, so it's the same thing as the list so far with checking what's inside. Let's see. So you can also do cool things with sets. So let's say I had a second set. We'll call it workers2 underscore set. And let's say I wanted the same exact workers but I wanted to add Angela and add Oscar too. Let me just space this out so it's a lot easier to see. So this is still valid syntax as long as you have the equal sign, you have the curly bracket here starting, you have the curly bracket here ending. It's just I'm making it easier for you guys to see everything. All right, now so likewise I can use this. I could use some set methods to get some data about what we got going on here between these two sets. So I can use workers set dot intersection. So it's going to return the things that these two sets have in common. That's what it's going to return. Okay. So we can see here that it returns Michael, Jim, Pam, and Creed. So yeah, that's the same. That's the similar things between these two sets. Likewise, there's some other methods that we can use. So we can use the dot union method. So that's going to print the union of these two sets, which is basically just workers two set, but it's going to print them combined, basically. So we got Michael, Jim, Pam, Creed, Oscar, Angela. And actually, I don't think I showed you guys, but let's say, so I know that I said that these sets are unordered, but let me show you actually what that means. So if I print worker set, Creed, Pam, Michael, Jim. All right. So far it looks just like a list. But let's say I print it again. The order's mixed up. It's if I did that with the list, it would print the same thing every single time. But with sets, they're unordered. It just print some in a random order, it doesn't really matter. So that's just what it does. That's the caveat about sets. And then you have all these methods that I showed you that make it easier to work with them. And yeah, so that's the most part for sets. That's pretty much all you need to know for the basics. And just one quick thing about empty sets, empty lists, and empty tuples. You just copy and paste from my notes here. All right, so we can have an empty list. You can either declare it using the brackets or you can use this list function. Same thing. You can have an empty tuple. You can declare it using this tuple function. So you can't declare an empty set. That's actually not right. This is actually something else called a dictionary. The only way you could declare an empty set is using the set function. So just run it. It's not going to spit out anything, but just run it for running it. So you see that these are all valid, but like you might run into problems when you do this. So it's just something that to keep in mind when you're declaring empty lists, tuples, and sets. All right, so that's it for today's tutorial. Hope you enjoyed it. Hope you learned.